Hey everyone, Mr. Fransky here. We got one more video for 1.5D. This is parametric functions or parametric equations. We're going to be able to understand and graph parametric functions and eliminate parameters. So vocab we're going to see here, definitely parametric, parameter, txy table, and then we'll learn how to eliminate parameters as well. So what the heck is a parametric function? Well, a parametric function is one that defines the x and the y coordinates in terms of some variable. So this might be like g of t and h of t. Okay, so they can be whatever you want, and the reason we call it a function is because this parameter t, so the parameter t, it defines x and y each time, and each parameter t gives a unique xy pair. And it definitely doesn't have to be something that ends up passing the vertical line test. All that's important is that each t gives us one unique xy pair. Okay, so not too bad there. So what we're going to do is we're going to have some kind of formula for x and some kind of formula for y, and then we're just going to get a bunch of points that are on these graphs. So let's go ahead and learn how to graph one of these. So I'm going to make a txy table, because each t is going to determine what the x value is and what the y value is. I usually start from -3 and go to 3. Okay, so if t is -3, then x is -2. If t is -2, x is -1. It's always going to be one more, so 0, 1, 2, 3, 4. And the y coordinate I can get by plugging into y, so plug t into y, into the y function. So we have 9 plus 2 is 11, 4 plus 2 is 6, 1 plus 2 is 3, 0 plus 2 is 0, 1 plus 2 is back to 3. We should go back up the ladder here. 4 plus 2 is 6, and 9 plus 2 is 11. Cool. Now let's plot some of those points and see what we got going on here. So, let's see, we got -2, 11. So I'm plotting the xy as an ordered pair. So we got -2, 11. Let's call that 11 right there, so we got it right there. And then we have -1, 6. 1, 2, 3, 4, 5, 6 right there. And then we have 0, 3. And then we have 1, 0. Did I do that right? No, it should be 1, 2. Right, you plug 0 in here, you get 0 squared plus 2, so 1, 2. And then we should pop back up the line. At 3, we're back up to 3. At 4, we're back up to, at 3, we're back up to 4. Wait, what am I missing? I missed one. When t is 0, we're at 1, 2. When t is 1, we're at 2, 3. And when t is 3, we are at 4, 11. I feel like I missed one. When t is 2, I'm at 3, 6. There we go. And then 4, 11 is where we round out. So it looks like it's a parabola. Okay. And parametrics are what we call directed. So -3 started us over here. So we can put arrows on the curve if we want to. It's not necessary, but it means that the function is being drawn that way. So as time increases, that's the way it's moving. So often they'll ask you to eliminate the parameter. It says eliminate there. Sorry, I kind of got cut off. So what that means is they just want us to solve for y. So all they're asking us to do here is solve for y. So what I'm going to do is I'm going to solve the easier of the two equations for t. Okay, so I'm going to search in, too far. I'm going to search in this thing for the easier one for t. This one has a square. I generally don't like squares, so we're going to use the x equals t plus 1. So if x equals t plus 1, then that means t is equal to x minus 1. So now what I'm going to do is I'm going to take that, I'm going to substitute it in for the t right there. So sub into the other equation. Okay, so that x minus 1 is going to go right in where that t is right there. So y is going to be equal to x minus 1 squared plus 2. Now it's important to make sure that your squareds and stuff are on the right spot. That's why we've done all that stuff with plugging in and replacing x values. Okay, I would just leave it like that. You could expand it out if you wanted to, but this shows really nicely that the vertex is at 1, 2. It's kind of nice. All right, why don't you give it a shot, and don't forget to eliminate that parameter. All right, let's try it together. So we got txy. So let's do the same t's I did last time. -3, -2, -1, 0, 1, 2, 3. There we go. Okay. So if we had -3, x is going to be 9, 4, 1, 0, 1, 4, 9. Right? It's just the square of the t coordinate. The y value, let's see, -3 squared is 9 minus 6 is 3. Negative 2 in there gives me 4 minus 4 is 0. Negative 1 in there gives me 1 minus 2, which is negative 1. 0 gets me, let's see, 0, right? And then 1 gets me 1 plus 2 is 3. And then we have at 2, 2 squared is 4, plus 4 is 8. 9 squared, 81 plus 18. 81 plus 18, 99. Is that right? No, 90. Yes, 99. What am I doing? Can't do anything right today. Let's see here. Let's back up a little bit. 2 squared is 4, plus 4 is 8. 3 squared is 9. 9 plus 6 is 15. That sounds much better. I was saying these numbers are huge. What am I doing? Plug in the x in instead of the t. All right, so now what I'm going to do is sketch a graph of this. So we have 9, 3. Right there. We've got 4, 0. Right there. We got 1, negative 1. Right there. We got 0, 0. Interesting. So it looks like it's come down like this so far. And then we have 1, 3. So that's the second time we've had a repeated x value. Then we have 2, 4. And then 3, no, I did that wrong. 4, 8. Let's see here. Make sure I did that right, though. 4, 8, yep. So 1, 2, 3, 4, and then 8 will be up here somewhere. And then we have 9, 15, which will be like here. Yeah. Cool. Once again, directed was going this way. Yep. Okay, so we got our directed curve. Let's try to eliminate the parameter. So I'm going to solve the easier of the two. Looks like the top one is easier. If x is t squared, then t is root x. Plug that into the y. So y is root x squared plus 2 root x. Simplify that a little bit, right? That is just x plus 2 root x. Kind of cool. All right. And I think that's it. So that's it for 1.5. I hope you guys learned something today. Love you guys. That's why I'm here. Have a great day.